What's up, guys? In this video, we're building a full-blown restaurant management API server with Rust. Sorry, the spelling is wrong. It's server with Rust. And we're using this framework called Warp. I'll talk more about it in a minute. Now, we'll have a database. The database is going to be simple. It's going to be SQLite. Now, Warp is quite a light web framework. It's not super heavy. So that's a huge advantage when you want to build something very quickly and something that works very fast, right? And then we are going to build a client. Now, please know that this is not a front end. I'm not building a front end client. And the thing is, sometimes I build a client in Rust itself because I get too lazy to test everything out with Postman, like, create those Postman collections and call APIs. It's really boring for me. And I'm also sometimes too lazy to write curl commands. So what do I do in those situations? I just quickly write a front-end client. It takes me less than like 15-20 minutes, and that's able to test out the entire server and see if all the APIs are working perfectly fine or not, right? So that's what I do. And I'll show you this approach. We'll build a client also, but that's towards the end. In the beginning, we'll focus only on building the server, which is going to be using the Warp technology, the Warp framework. And I'll take you through the project and how it's structured. But before that, I just want to tell you that this is what I'm talking about. Warp with Rust is not Warp terminal. That's something else. That's a terminal built with Rust. That's something else. I'm talking about the Warp framework, which is an extremely popular framework. So the Rust community is very small. As you know, it's not a huge community like Python or JavaScript. And still, even though the Rust community is small, still this framework is used by 24.5 thousand people. That's a lot of people. And it's being contributed to by like 177 people. That's a lot of people contributing, a lot of people using it, and actually I've seen a lot of people use it for POCs, MVPs. Like, let's say you want to build a full production level application. Before that you build a POC or an MVP, you would want to use Warp because it's just so fast to get started with, just so fast to start building very quickly. It's very lightweight. I mean, there's no fluff, there's not too many features that might confuse you, right? Just in like 5 lines you're good and ready to go. Just 5 lines of code. And this is what it looks like on the crate. So if you want, you can read some documentation, but mostly I'm going to take care of that. So the way I've built this entire project is you'll never have to look at the documentation. If you just use what you'll end up building at the end of this video would be some code that you can always use in your other projects in the future. Okay. Now this project is going to be slightly long because we're building a complete restaurant management application, and you know that when I talk about restaurant management, I'm going to be taking reference from my very famous restaurant management project, which is part of my 53 Killer Golang project series. If you've not watched it, you must watch it. And if you're a Golang developer, and it's possible that you already watched this one, this is the one that I'm taking reference from, and we're building a Rust version of it. Not exactly the same, because this one obviously had a lot more features, and I'm not gonna spend like 6.5 hours, but we'll do something big. We'll do something good, basically. All right. Now today's video is going to be part of the 50 Rust project series. I already have 36 videos in this series, and today's video will also be part of the series. So make sure you check this out. All of the code from the series is there on my GitHub. So I'm Akhil Sharma 90 on GitHub. In case you have trouble running today's code or building today's code with me, you'll find it on GitHub, so don't worry. Now there's also a lot of more awesome stuff on this channel. There's the Ultimate System Design series. There's the Ultimate AI and LLM project series. You must check it out. In 2024, obviously, there's the Technology Architecture series. So if you're new to this channel, make sure you subscribe. Make sure you check out all the other awesome free stuff. Before we get started, just want to tell you about the 6 AI plus Golang projects, advanced projects course that I have. The link of the course will be in the description. So you'll get to build 6 projects using AI, like the Terraform AI Copilot, the Kubernetes AI Assistant, Terminal AI Assistant. 2024 is going to be the year of AI. If you're not learning AI, I highly recommend you to do that. Anyways, so going back to our project, we're going to be using SQLite. I think I told you about that. And we're going to be having our client, server, and Warp. Now we'll have routes, right? So for our restaurant routes, we're going to follow the very standard system that you have. Like, you'll have routes, you'll have handlers, you'll have some common DB functions, and then you'll have some specialized DB functions, which are like, these will be in your model.rs file, and these will be in your db.rs file, which is to do with database. And this will be in your handler.rs file and your routes.rs file. That's how we'll structure the the server, and then we'll have some models. Let me talk about that as well. But let me take you through what these functions will look like. So you'll have a route that will help you create a table, because it's a restaurant. So you'll have a table, you'll have a menu, you'll be able to list the tables, you'll be able to list the menus. Okay, so you create the table, create the menu, list the tables, list the menus. Straightforward till now, right? That's what a restaurant management system is supposed to do. Then you are able to also list all the orders that are in your system. So order will obviously take in the table number, right? And then the items. So you can also delete items from the order, and you can get a particular item from the order. So these are the different routes that we'll be building. All right, now these will have corresponding handler functions. Now some routes might require like multiple handler functions. So that's why you'll see that even though there are like 7 route functions, there are 9 handler functions, because obviously sometimes you want to do more things, and one route might require more handlers. So you have the create table handler, you'll have the list table handler. So you'll create table, list table, create menu and list menu. So both of these here. So I'll just reverse the order. So create menu and list menu. Then you have the create order and the list order. Okay, so all these 6 things are very, very straightforward. Then you have the delete order item and list order items for that particular table, and then you get the order item for that particular table. So you have all of these things for the restaurant handlers. Now there are some common DB functions which help you create things. Like in the beginning, you want to create the table, create the menu, create the order item, all of those things. Those are some common DB functions. And then you have some specialized DB functions, like for example for a table. Now the table, menu, order, response, and order item, these are some of the structs. Sorry, I didn't mean models, I meant structs, even though they'll be in my models.rs file, but these are all structs, and they have for example, we have a struct for table, we'll have a struct for table response, menu response, order request body and order response, order item and order item response. So these are the structs that we'll have in a project. So you know why we have structs is basically to store the data, or to represent data in a particular way before we send it off to the database, because the database understands different language, the Rust understands a different language. So to tell data, to tell Rust, hey, this is what a table looks like, this is what a menu looks like, this is what an order item looks like. That's how you have structs to structure the information. Now you have the restaurant specialized DB functions. So for table, so for example, what we're doing here basically is taking all of these structs and implementing some functions for them. So we'll use IMPL, as you guessed, right? So we'll use IMPL in these functions. And then for the table, we'll have create list, get existing table ID function. For menu, we'll have create list and get existing menu ID functions. For the order response, we'll have create list, get existing order ID, calculate total cooking time for that order, because for orders we also want how much time it took to cook the entire order, and then which all items does the order response have. The order item, so you want to create the order item, you want to list all the order items, right? And then you want to get the order item, you want to get existing order item ID and add quantity of existing order items. Okay, so now from a 10,000 feet perspective, I'm sure all of this makes sense. It's all about orders and menus and order and tables and order IDs and all of that stuff right now. But then once we get into it deeper, once we actually start writing code, things will become much, much clearer. Now here's your client. So like I said, we'll build a client. We'll be in Rust. So Rust client and Rust server. So we'll run the Rust server, and we'll use the Rust client to call all of the functions from the Rust server, or call all of the APIs, just to know that everything is working fine. So instead of creating our own Postman collections, like painstakingly creating those like with the UI, click, instead of that, or instead of creating our own curl commands, which nobody seems to get right, we'll just create a quick Rust client, write some Rust code in just one file, and then we'll be able to call all the APIs from our server, right? So we'll be able to create tables, create menus. So we'll just basically be calling our APIs at the particular routes, sending some data, getting the response, and confirming when everything works fine, and then printing it out to the terminal. That's all we'll do. So create menus, ordered simulation. So when ordered simulation, we'll actually create an order, get all items from the order by table ID. We'll get specific items from table. We'll remove one item from the table and see what happens. So that's how our ordered simulation works, right? So we'll create tables, create menus, and simulate a complete order. That's what our client will do. So this is something we'll do towards the end, but we'll focus on this right now. So let's get started with the code. First, let me show you how it works. So we have the project, and I have the application server and the client server. So first, I'm going to run the application server, and in a separate tab, I would like to run the client server as well. why this tab is not working. Okay, framework, sorry. And the client server. So I have both these tabs open. So here, let me make it smaller. And here also let me make it smaller. Okay, so on the left is the application server. So I'm going to say cargo run. So it ends up starting the application server. It creates the table, menu table. Then when I say table, I mean table, like in a restaurant there's a table, that's the capital T, and table is obviously the database table, the table in database. That's why it says table. And then the table for the menu, table for the order item, and then you start running the server, right? And here also I'll run cargo run, and we're going to end up calling the APIs. Okay, so in our backend we're calling all the APIs. So we say created order for table 2, table 1, table 5, table 3, table 4. So what we're doing is trying to run all these APIs concurrently. So that's why whichever resolves faster. So it doesn't have to process an order. I'm doing everything concurrently. So we're going to be using the request, REQWEST, the request library. So we'll create all these tables. Then we'll create the order for table 5, table 1, and so on, order for whichever table. And then we are listing all the items from that table, from a particular table. And then we're gonna get the menu and remove the menu from a table and so on. So multiple processes from the client just to test if our APIs work successfully or not, right? That's what we're doing in the client server. This is what you're doing in the application server. Now you know how the project works, right? And this is what we're building. So what I'm gonna do is I'm gonna cd out of this, and I'm gonna create a new project, cargo new restaurant warp, because we are using warp server, right? So restaurant warp and YT, which is for YouTube, and I'm gonna cd into this, and I'm gonna open up VS Code. Now I do use Rust Analyzer at times, right? But I'm going to keep it off. It's very distracting for me when I code, at least. If you're not comfortable doing that, you please keep it switched on. Now, if I have my Rust Analyzer off, this means that I'm going to have a lot of typos. I'm going to make a lot of mistakes while coding. But please do not worry. That's how I work. I make a lot of mistakes while coding, and I completely trust Rust. So whenever we run the code at the end, it'll tell me exactly the issues, and we'll be able to fix everything later on, right? So the thing is, you trust yourself, trust Rust, and everything will be fine. And please don't get irritated or agitated if I make a lot of mistakes on the way. It's only because I'm like totally chill when I code, and I fix everything later on. That's how the approach has always been. That's how I always work. That's how I do it in all the videos. If you have been following this channel, you already know, right? So I don't need to tell you. But in case you're new, just wanted to inform you. So here I'm going to have the client server. So what I'm going to do is I'll have to create one more server. So I'm going to say inside this cargo new, I'm going to say client server, right? So now I'll have a client server also inside it, this one, and then I'll create a new folder called app server, and gonna shift all of this inside that. So now we have our app server, we have our client server. Everything is fine now. Everything looks good now. In our app server, right, I'm gonna have a few files. I'm gonna have obviously my main.rs. I'm gonna close that off for now. I'm gonna have, close that off for now. I'm gonna have my db.rs. I'm gonna have my handlers.rs. Then I have my routes.rs. Okay, so I have my routes, db, handlers, and there's only one thing left. Right, so if you look at the diagram, so please keep referring to it because I have this open on my other screen, so at least I'm referring to this. The other thing that's left is we have this in DB. We're going to have this in models, like I told you. So this will be models.rs. So make sure you create a new file called models.rs. So you have DB, handlers, routes, and models. Now you start with main.rs. Okay. Now in the main.rs, what do you have? You want to have all of these modules. You want to have your DB. You want to get your handlers. Right. So main is basically something that brings all of the project together. It's like the binding force. So you want to have your routes. You want to have your models. I always forget models. Okay, and then I want to have warp, of course, warp. Okay, so here I'm going to get the module for DB, module for handlers, module for routes, and module for models, which is basically all of these other modules in my SRC folder. And I'm going to use warp because that's the one I'm going to use to create my server. And here I'm going to say Tokyo main, because that gives me access to async. So I use async function main rather than the regular function main. So in my async function main, I'm going to, because I have my DB, which is my DB module, I'll have a function called the initialize DB. I don't have this function yet. I'm going to have this function soon, but I'm going to be calling it, right? And the other thing I want to do is I'm going to create routes. Basic stuff. You need the DB and the routes for the server to run, otherwise there's no point. And you have your restaurant routes. So running the server. And here I'm going to use warp. There's a function that I get with warp called the serve function that creates a server for me. And here I can pass my route. So I have all the routes and something called as restaurant routes, which is going to be in my routes module. As you know, this function will be there in my routes module. And I'm able to access it using this variable called routes, routes.with, and warp trace request. That's it. That's all I need to start my server. And I'm going to say here dot run, and I can tell it the port. So I'll say 127.0.0.1, which is, as you know, my local host, and the port 3030 dot await, and that is it. That's all I need to run my server. Just this much. This is actually just one line. I've obviously, as you know, we keep it on different lines, but this is just like one line of code. Your warp server has started along with your routes, and your DB has been initialized. So that's all you want to do in your main.rs file. That's it. You're done. Now in my db.rs file, I want to use SQLite. Now in this series, which is this 50 Rust project series, I've already covered how you connect with Rust SQLite, which is SQLite. How do you add SQLite to a project? I've covered all of this already, so make sure you check out those videos, right? And I've used exactly SQLite. So I've shown you how you can leverage the connection from SQLite to do it. So all the projects that I make, they're ordered in the increasing order of difficulty, and they all build on top of each other. So whatever we're learning right now, because we've already seen how Tokyo works, we've already seen how request, REQ, WEST, how that works. We already know how SQLite works, and that's why I'm making this video, because you can bring all of that together, right? And it won't be confusing at all. If I were to show you this as the first project, you would completely lose it. But now you've built your foundation with doing all of those projects. I'm hoping you've done all the projects in that series, and now you're doing it. So just you'll be able to build up very fast and understand everything, right? So the public function get DB connection. And you leverage connection here that you got from SQLite. This is your connection string. So let con is equal to, you use connection that you got from SQLite, and you use open, you get the restaurant dot db dot expect fail to open SQLite connection And then you want to create the function which is initialize db. That's the function that we'll create. So we'll say public function initialize db, and in that function I'll just print out that I'm initializing the database. So initializing database. Okay, and I'm going to open. So to initialize the database, first things first, I'll open the connection to the database. The database in my case is called restaurant db dot expect. So with SQLite, as you know, if the database doesn't exist, it'll create the database for you, not a problem. So I'm going to say failed to open SQLite connection. Then I'm gonna enable foreign key support, and then after you've opened up the connection, you will say con.execute. Now to execute any commands with SQLite, after you have the connection open, you just have to run this execute command. Okay, so the first thing I'm going to run is pragma foreign keys equal to on, and then dot expect failed to enable foreign key support. Okay, then you'll print out creating tables. This is what we saw in the terminal when I showed you the demo of the product of the project, that we print out that, hey, this table is getting connected, this table is getting connected. So there was the table that was getting connected, there was the created, sorry, and there was the menu table getting created, then there was the order table that was getting created. So I'll write the order table as well, and there was the order item table getting created. So for the table, I'm going to have 4 functions here for creating these 4 tables. So the first function is going to be create table, create table if doesn't exist, and you pass in the connection here, and then expect failed to create table orders. Sorry, this is gonna go here. Okay, and here we have the same thing, exactly the same thing, and here I'm gonna say the connection that I'm gonna accept is equal to connection SQLite result. What you get back from this function is the SQLite result, and there will something that they'll go in this function, right? So I'm calling the function here, and then this is the actual function that exists out here. Similarly, I'll have functions for all of these things. So here it was create table, here it will be create menu table, here it will be create order table, and here will be create order item table. Makes sense? And similarly, I'll create these functions also, like 4 times. And here it will be create menu table, create order table. So I'm just creating all these tables if they don't exist. So create table, menu table, order table, and order item table. And inside these, I'll be running the actual SQLite functions. So it's con, and you know how to run the SQLite functions with con execute. And this is what the function looks like. Create table if not exists tables. And what all will the table have? So ID integer, ID is integer, which is the primary key. Code, that is text, not null, and it will be unique. And create menu table if it doesn't exist. Same, I'll have the same 2 lines here. And here, instead of create table if not exists table, so it will be create table if not exists menus. And the other thing I'll change are the actual fields. So there'll be ID integer primary key, and then there will be name, text, and not null. Then you have the create order table if not exists. So I'll have the same 2 lines going here as well. So create table if not exists, instead of menus, it'll be orders. And in the fields, I'll have the ID integer primary key. I'll have then the table ID, which is integer, not null. And I'll have the foreign key, which is table underscore ID. So here it's orders, right? And any order, for any order, you also have to store the table ID. So with that order belongs to which tables. That's why we have a foreign key table ID. And we're going to be referencing the table's ID, comma unique, table underscore ID. And everything else is the same. And finally, we have the create order item table. So we'll create the order item table. I'll copy and I'll paste this here. And I'll create table if not exists. It will be order underscore items. And the ID is the same, integer primary key. Then you, instead of table ID, I'll have order ID. And store the order ID here. Then I'm going to have the menu ID integer, not null. Then I'm going to have cooking time there, cooking underscore time, not null, comma quantity. So these are all the things that I have in the order item. So I have order for a particular table, and then I have the item, the order item in the order. So the order item basically will have the ID, the order ID, the menu ID, so which menu is it belonging to, which order it's belonging to, okay. And then it has the cooking time for that particular order item, and how much is the quantity required. So like, let's say if you're ordering pizzas, you'll say quantity 2 or 3 or something like that, and quantity will be integer, not null, default 1, comma. You have a foreign key. Also the foreign key in this case will be the order ID. So I'm going to say foreign key order underscore ID, and it references orders. And then I have another foreign key, so I'll just remove this for now. And I'll have another foreign key, which is menu ID, and it references menus. Everything else is the same, okay. So just to go over everything again, very quickly in this file. There's not much happening, but still it's possible that you might get confused. So I'll just go over it again. We first create a database connection using this function. Now, once we have the database connection, we're able to use the leverage the database connection with the help of just conn. You don't have to call this again and again. So once you have conn again in this function, the initialize db function, you're gonna run all the database functions that you want with the help of execute. So the first thing is you say execute, and everywhere else also you notice you're running con.execute, and all you have to do is just say con.execute, and with SQLite you're able to run actual database commands. So what we're doing is basically we're writing everything in the SQLite language, which is the SQL language, and first we say pragma key is equal to on, and then we create a table, table and menu. So every single time we'll print it out, and then we'll try to create the table. So to create the table, we'll call these functions where we're passing the connection string. So 4 times we'll do that for table, for menu table, for order table, and for order item table. And what we're doing is we're calling the respective functions. This function exists here, this function exists here, and so on. So for table, all we're doing is we're returning the SQLite result, but inside the function we're just using con.execute, which the connection string we've received here. So of type connection basically being this, and we are running a SQLite SQL query basically. So create table if not exists. If the table doesn't exist, so we'll create the table, and here are the things that it'll have. It'll have the ID and the code, and for menus will have an ID and name, and you'll have, and in the menu there will be order items, of course, like for example pizza, pasta, burgers, or whatever you want to order. And then you have your create order table if not exists, so you will create the order, like every order will have multiple order items and it will belong to a table. So you'll have its integer ID, and you'll have the table ID, which table has placed that order, and then you have the table ID references, foreign key, blah 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 blah, all of that. Then you have your order item. Order item now has the integer, then it has order ID and menu ID, integers, both of them integers are not null. And then you have the cooking time and the quantity, and then you have your foreign key, which is the order ID. So order ID is the foreign key in this case, okay, and which is basically orders ID, and then the menu ID is also foreign key, which references menus ID. So everything is now very well connected, right? So the order item is referencing the order and the menu, and the order itself is referencing the table. So that's how we've connected everything. So our database is complete. Now the database, as you know, database related stuff is at the center of everything. This is why I decided to create this first before the routes. And now, so we have the main function, which is starting the server. We have the database related stuff, which is creating the tables. And now we have to do everything in between, which is creating the routes, creating the handlers, and creating all the other model related functions, which will help us bind things, like for example, getting all the tables, getting all the menu items, blah, 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 all the stuff in between. But we have the foundation and we have the top floor, right? And we just have to build everything in between now, which shouldn't be difficult because we now have an idea of what we're doing. We also have a nice, we've also had a nice view of what we're doing anyways, right? So we're done with this. We're done with creating these 4 functions just now, right? Creating tables, because without this we can't really do anything out here. So we'll now work with the specialized DB functions, but before that we'll create all the routes, then we'll create all the handlers, and then we'll create all of these. Make sense? Along with the structs. So let's get started. So let's go to the routes, and the context for routes is that we got all of these will be in the restaurant routes function. That's the one that we're calling. So to start with, what I'm going to do is I'm going to go to routes.rs. I'm going to create a public function, and I'm going to call it restaurant_routes, and this implements, I use filter from warp, extract real reply, comma error, is equal to rejection plus clone, and here we'll have let routes equal to create order route. Right, so we're gonna have all the route functions that we'll create here on top of this, obviously, and here I'll have dot or create table route, and all of these routes that I'm creating are basically these, which is create table route, create menu route, list table route. So these are the routes that I'm creating here at the end. So dot or, and it's going to be create menu route dot or list tables route dot or list menus route dot or list for all underscore orders underscore route, and then I have or delete underscore from. Now in case you don't have access to this Whimsical, which is completely all right, I'll just open this up very quickly, just take a couple of screenshots. So screenshot number 1, screenshot number 2, screenshot number 3, screenshot number 4, so that you have access to this. You can also look at this while you build along, right? Screenshot number 7 and screenshot number 8, right? So now you have everything. So you've taken screenshots, and you can just keep combine all of that into your own Whimsical very quickly, all the screenshots into one board, and then look at it. So you don't have to wait for me to share the board or anything. So delete item from order route. It's great to look at a visual representation while you're coding, right? So everything makes sense. And so delete item from order route, and then you have list underscore order items for table underscore route, and then you have get item from order underscore route, and then you have routes dot recover handle rejection. So this means that we have a function for handling rejections, and then we have functions for all of these things, and that's what we will create now. So we'll have the first function, which will be async function handle rejection. Okay, and then we'll have all the other functions, which is public function list all orders route, and then you have your create order route, create underscore order underscore route, then you have delete item from order route, you have list tables route, then you have create table route, so public function create underscore route, and list underscore order underscore for table route, and get underscore item underscore from order underscore route, and list menus route, create menu route. Okay, right, so you have a function for this handle rejection, And you have function for all the other things as well, like listing all order route, creating the order route, deleting listing tables, creating table route, and so on. Now, the thing is, all of these, what you want to know is, all of these routes are going to call functions in the restaurant handlers. And we have 9 of these handlers. What I'm going to do is I'm going to import all these handlers on top, because I'm going to end up calling those handlers from these route functions. So why not have them handy? So I'm going to say use create handlers, which is everything from my handlers.rs file. And I'm going to extract my handlers. I'm going to import them out here. So create order handler. Even though I don't have them right now, don't worry, we'll be creating those obviously. And that's the whole point of the visual planning, that we know that these will exist in the future. So it's best to just import them right now and call those functions from the route. So the functions in the routes call the functions in the handlers. Functions in the handlers call the functions in the models and db.rs. That's how the flow is happening. So functions from the routes, that's why there's an arrow, call all the functions from route restaurant handlers. All the functions from restaurant handlers call all the functions from common DB functions and the specialized DB functions, both of these actually. So this should ideally look like this. Make sense? This is what it looks like. And that's what we're doing. So we're importing all the handler functions here. So we're going to say list table handler, comma, we'll say create table underscore handler. And I hope you appreciate that I'm going like line by line. I'm going slowly, so that even if you're not very good with Rust, you should be able to understand everything. That's the whole point, that you relax and you build along with me, and then you learn also at the same time. Create menu underscore handler. Because building alone, doing stuff alone is boring, right? And especially when you don't know something and you don't have a way to build it, doing something alone is very boring. And this is why I make all these videos, so that you don't feel bored, and you actually, instead of just learning concepts all the time, you actually build stuff on your own, along with me obviously. And that way is, let's say it's the weekend and you switch this on and you just start building along with me. By the end of the weekend, you'll have a nice little project that you can put in your portfolio, right? So instead of wasting time on weekends, this is a really viable strategy, like really cool thing to do. Anyway, so we have now our 9 handler functions. And then we're gonna use a couple of things. I'm gonna use warp, because we're creating the server in warp. So I get this filter that I was talking about from warp. So I'm going to say, I'm going to get the filter from warp, I'm going to get rejection and the reply, everything from warp. And then we get SQLite connection, and then you get create db get db connection, and use standard convert and value. So in my DB crate, I created this function called get DB connection. This will always help me connect to the database. That's why I have it as a separate function, and that's why even I had to create this again in initialize DB. That's completely all right, but I want to use this as a separate function in my other files. That's why I created it. So now I have the async handle rejection. So here I'm going to say error rejection and result real reply comma rejection. Now we can have a few types of errors. So the first error I'll handle for, like handling rejections, right? So handling all these routes, we have functions for these routes, but then what if something goes beyond that? How do you handle it? So that's how you say routes.recover handle rejection, and you handle all the rejections, the possible errors that can happen in a separate function called handle rejection. So what's the first thing that can happen is that I'm trying to hit a route that's not found, that doesn't exist. So I'm going to say error is not found. And what am I going to do there? I'm going to say okay, and warp reply with status. Right. So with warp, what I sometimes feel is like it's almost like you're talking or you're writing in natural language. So it's almost like okay, warp reply with status. Right. It's almost like speaking natural language. That's why I like this framework a lot, and that's why the learning curve for this kind of a framework is very less. That's why for beginners, I highly recommend using something like Tide or Warp, which is like very easy to use, as opposed to something like Actix. Actix can really, you can really break into a sweat when working with Actix. Like I've been working with Rust for more than 4 years now, and sometimes I get a little confused with Actix because there's like so many features, almost like the equivalent of Gin and Gonic in Golang, right? Whereas Tide and Warp are so easy and chilled, and you can make mistakes, you can get away with it, not a problem. With Actix, it wants you to be an experienced guy with Actix. That's the difference. I think that's what I felt, right? And what do you want to reply with the status? So here I'm going to say warp reply JSON &format error warp HTTP status code not found. Not found status code. Okay, make sense? Then you'll have else if let some dot find warp filters body deserialize error okay warp reply with status, and the same thing, basically warp reply JSON &format error failed to deserialize request body, and here we're gonna say bad request. So warp HTTP status code bad request. Okay, and then we have else okay warp reply with status JSON &format HTTP status code internal server error. Okay, so you're handling everything. So you're handling the request not found, and you're handling bad request, and which is basically a body deserialization error. So it'll say fail to deserialize body request body, And for everything else, there's the internal server error. So we'll reply with 500 internal server error. So all three major types of issues, like the route not found, it was a bad request, it's basically problem with deserializing body. And then with the internal server error, we're handling these three conditions, which are obviously the most important conditions. We've handled those. Now, I'll create a function called widDB, and so it'll help me get the connection to the database from here. So I'll say with underscore db, and I'll need it later on. So I'll just create it function with underscore db and pl filter extract connection infallible clone warp any dot map. And essentially what's happening here is you're calling the getDB connection function. Okay, so you have something called as the getDB connection function that you're importing from the DB crate. So this is the function which helps you open up a connection to the database. And we have this function called widDatabase that helps us create the connection to the database by calling the getDB connection function. And we're going to be using this function here in one of the functions. So that's why we needed it. Now you know what's happening in this line, right? You know what's happening. It's basically returning the DB connection with the help of the getDB connection function. That's all that's happening. But it's just like one line of code, 1 or 2 lines, but it can be confusing. So let me explain to you. So you know what's happening, but you don't know how that's happening. So let me quickly explain it to you. Now Warp, our framework, has a concept called filter, with the help of which you can create HTTP routings. So you can process HTTP requests basically, and with the help of any, what you can do is you can process any type of request. So for example, it doesn't have to be a GET request or a POST request or a PUT or a delete request. It basically means any type of request can be processed when I'm saying warp any. My map is basically saying that getDB connection, which is the function, is going to be run as a closure, and it won't be there won't be any arguments attached to this closure, and that's how it's going to run. So this is what this does. Now filter, like I said, is a concept that belongs to Warp, and you have something called like extract. So you're telling Warp or this function to extract particular values. For example, connection being the connection to the database in this case. That's what you'll extract. And when I say error infallible, that basically means that this cannot create an error. So it's infallible. It cannot create an error. I have covered this in the previous videos. I've covered actually extract, infallible, all of these things. I've not covered this maybe, but yeah. But I'm just repeating anyways in case you're not very comfortable with the syntax. But this is something that we'll be using in all of the functions now. So all of these functions that you see that are going to be routing functions, this is how we're going to connect these routing functions to Warp, saying that hey, this IMPL filter, IMPL filter, IMPL filter, to tell Warp that these are the functions for those particular routes that you will be using. Okay, that's how the routing works. So if you've used something like Rocket, if you use something like Actix, you'll have to define the routes like slash and then the route and then the function handle, like the route function, the handle function. You don't have to do that here. You just have to say filter blah 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 blah, and then you'll be able to run between these functions with the help of the routes. Okay, so now the plus clone thing is also something that probably you've not seen before, but it's the same as the clone that you see usually in Rust, which is saying that this will be clonable in the sense whatever you're returning from here will be clonable, meaning that the DB connection that you're sending from here is not the original copy. I'm sending a copy of it, like the clonable copy. That's all I'm saying with the plus clone here. Okay. Now all of these functions that we have, they're going to have a lot in common. First thing is they're not going to have a lot of processing at their side. In a sense, they won't be processing a lot of data. because their job, all of these functions' job, is to essentially just call these handler functions that exist in my handlers.rs file. They don't exist right now, but they will. Like, you know, the route function calls the handler function, they'll call them the model function. That's how they'll happen. So these functions basically are going to call these functions. The only reason these functions exist, the whole layer of routes exist, is because we want to define the routes, how it's going to look like slash orders, slash tables, whatever it's going to look like, and the method that's going to be required to call that route, like get or post. So that's the thing we want to define. And then finally, just call the handler function. That's all we're going to do in all of these functions. So we can go through them really quickly, actually, and that's what we're planning to do. So for this function, what you want to do is you want to say impl filter, and instead of filter, I say in front of filter, I say extract is equal to impl reply, comma, error will be equal to rejection plus clone with a capital C. And in here I'll define the function. So to define the route, all you have to do here, right? So this is the list all order route, just to be mindful of that. So to define a route, this is how I do it. I define the path. The path will be order. So I know that I'm going to hit the, if somebody hits the slash orders path with the get method. So when I have to define the get method, I also get that from warp. I get the path from warp, I get the get method from warp, everything I get from warp, and at the same time I want to write with db dot and underscore then, and then you know what this function is supposed to do, right? It's supposed to basically call the handler functions, list order handler function with the connection. So list order handler function is out here. As you can see, this is coming from our handlers. That's where it's being imported from, and that's the function you're going to call. That's the function you're going to call. That's all that's happening here. Now, like I said, you know, all of these functions, they're going to look very similar. So what I'm going to do is I'm going to copy this, and I'm going to quickly paste it here, 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 paste it here. Okay. Now, when you copy and paste something, just be very, very mindful of what you've done and where you've copied and pasted, because if you leave something which was like the original copy and pasted stuff, which you didn't end up changing, then obviously that'll lead to a lot of errors in the code. What we want to do is we want to change some things here, of course, right? So this part will be the same, impl filter extract, which is basically your reply and rejection. That's going to be the same everywhere. But what's going to change are the paths. So to create the order, the path is going to be orders slash create, and instead of get, it'll be post, and it'll be with db. But there will be one more thing, and that's your body JSON. So what does that mean? That basically means when you're creating an order, you're passing the body, the request body, to the API, so that to the route, so that it can use the JSON body and create something, right? Create the new order. Now, along with the connection, you're supposed to pass the request underscore body, and here also connection, comma, request underscore body. So that's it. That's your create order route function, right? So very quickly, we got it done very, very quickly, if you notice. Now, the delete item from order, very similar. The only thing is the route is going to change. So it's going to say i64 slash items slash i64, and instead of get, it's going to be delete. And here, along with the connection, you'll have to pass the table underscore I. Now you know that a item from the order, right? It has, which is this basically order item. It has the menu ID and the table ID and or like whatever it has some multiple things. So I'll have to pass multiple things, right? Table ID and menu ID and that stuff, right? And the connection itself. And then here, so one small mistake that I've made here is that it should have been the create order handler. I'm going to call it the create order handler. Yeah, don't make that mistake like I did. And here is the delete order item handler. So delete order item handler, and here we'll pass the connection string, the table underscore ID, and the menu underscore. Okay, that makes sense. So now that's sorted. You have the delete item from order route as well with your wob delete and with DB, and then with table ID, menu ID, connection, delete order item handler, connection table ID, menu ID, everything getting passed with the right path, right? So make sure you've changed the path and the method that you're using here, along with the function, the handler function that's getting called. Okay, so now comes the list tables route. So obviously the path is going to look like this. Okay, the path is going to look different, and whenever it's list, it's obviously get. And here, because you're getting all the tables, you don't have to pass like an ID or anything. So you don't have to pass anything, just the connection. So this function is already done. It's sorted. The only thing you want to change is the list table handler. That's the thing that you'll change. Then you have the create table route, and again, you know, here when you're creating something, you'll be passing the body JSON. So in the create table route, I'll pass the body JSON, and here it'll be tables and / create. Okay, and here along with the connection, I'll pass the request underscore body and connection comma request underscore body. And then you have the list order items for table route, and here I'm gonna have, instead of orders, I'm gonna have tables /i64 / items, and then here I'm gonna pass, along with the connection, I'm gonna pass the table underscore ID, and here again I made a mistake out here. Instead of list order handler, it should be, I need to change the name of the function. It should be create table handler, right? So whenever you copy and paste stuff, you're going to make a lot of mistakes. So you have to be very, very careful, especially if you're new, because I know when I'll make mistakes, I'll easily handle them later on when I run the code. But then if you're copying and pasting stuff, that's why I always am kind of against copying and pasting stuff from your own code into your own code, basically, right? So if you do that, you expose yourself to a lot of new errors and issues. But anyways, to save time, we had to do it, and we've done it. So so this is our list order items for table route. So tables / items is route, and pass the table ID, connection with table ID is being passed to the list order items for table handler function. Now the next function is the get item from order route, right? So here you'll have the tables and the items. So I'll say tables /i64 / items /i64, and here along with the connection, I'm going to pass the table underscore ID comma the menu underscore ID along with the connection, and the function I'm going to call is the get order item for table handler, and pass in the connection comma table underscore ID comma menu underscore ID. So that's how we've done it. And then finally the function list menus route, and here we have the menus path, and that's it. Just pass the connection. You don't need any IDs here because we're listing all the menus. And then finally the create menu path. You know what happens when you create something, right? You need the body. So let's copy paste that here. And here also you need the body, and instead of this you'll say create menu handler and connection comma request body, and just make sure you get all the functions correct and the routes correct. So you say menus / create. Okay, so here it's menu slash create. Just go through everything again. You have the body, you have the connection slash request body, and here you have the create menu handler with the connection and request body. Okay, so this is perfect. In the list menus route, you have the slash menus as the path with the get. Here, if you're creating the menu route, this will be post, right? So I'll make that change quickly. It should be post. When you're creating something, it'll be post. When you're listing something, it'll be get. So here you have get with menus. Passing the connection in the list, it should be list menu handler function, right? And yeah, everything else is same. And then you have the get item from order route. Here you have slash table slash items slash I64. Everything is fine. You are using get, passing table menu and menu ID connection, and get order item for table handler, passing the connection, table ID and menu ID. Okay, that's perfect. Then you have the list order items. So here also you'll use list order items for table route. Here you'll use get, of course you'll use with DB, and table slash items. And then the function you're using is list order items for table handler, passing the connection and table ID as well. And then you have the create tables route. This one, it's tables slash create, and you'll have to be using post, not get. Okay, and with post you'll be using the create table handler function with connection and request body. And then you have the list tables route, which is the slash tables path, warp get db, and then connection and list table handler connection. Then you have the delete item from orders. So there you have the order slash items. There you have the delete method. All right, delete method. And then you have, you're calling the function delete order item handler. Perfect. And finally, we have two functions left, which is the create order route. There you the path is order slash create. Post, you're using post there. Create order handler and connection request body is what you're passing along with the body. Make sure you have the body. Whenever you're using post, make sure you have the body. And then you have the list orders route, where you're using get or orders path and then list order handler function. So that covers this routes.rs file. So now we've got models and handlers left. That's what we have left, right? Before I begin with handlers, I just want to quickly create some models. Models basically will have all of my structs. For example, it'll have my table struct. It'll have my table response struct. Right, everything that I showed you on the whimsical board, basically. And the table response. All right, then I have my menu struct. So I'll have public struct menu. And then my menu response. My order request body and order response. Order with a capital O. Response body. And order response. Right, and my order item and order item response. So I'll have my order item and order item response. Okay. Now, on top of each of these, I'll say derive and debug, comma, serialize, comma, deserialize. Now, if you've watched the other videos on this series, you know what is serialize and deserialize. It comes from the Serde library. So we're gonna get our hands on Serde, which is basically serialization and deserialization, which will help us to change things from JSON into the struct and struct into JSON. That's serialization and deserialization. And inside the table, I can use Serde skip, which will skip the serialization and deserialization for a particular field. For example, in this case, the ID field. I don't want this to go through serialization and deserialization. Then I have my code, which will be treated as a regular code thing, which will go through serialization and deserialization, so it will be string. And then I have my table response. Here also I'll just copy and paste this first. Put a line here. And here again, I'll put this everywhere actually. And on top of all the structs. Okay, so now you have that on all the structs. And now all the thing we have to do, the only thing we have to do now is to work with the fields in the struct. So we have ID, table response, we have the ID, which is I64, and we have the code, which is string. Then in the menu, I'm again going to use Saturday skip in the menu, and here I have my ID, which is I64, comma my name, which is string. Okay, and for my menu response, again I have these two things, which is ID64 and name string. Now in my order, before order response, right, this is not response body, this will be request body. And here I'm going to have two things. I'm going to have the table ID, which is I64, and then I'm going to have the menu underscore IDs, which is rec I64. Now at any point of time you're not sure which fields will go where, just refer these, because this is where we are referring to when you're looking at the fields. And then we have the order response. The order response will have ID, it'll have the table ID, okay, and it'll have the table name, which is string. It'll have the total cooking time, which will be I32, and it'll have the menus, which is order item response. Okay, and then you have the order item itself. The order item, here again I'll use the skip the Saturday skip. So I'll go to the table and table or the menu, and I'm going to just pick this up, put it here. Okay, so in the order item we'll put it here, and then the first thing I need is the ID. Then I need something called as the order ID. Then I need the menu ID. Then I need the cooking time. Alright, so that's my order item. Now in my order item response, I'm going to have all of these things, which is the ID, the order ID, the menu ID. Apart from this, I'll have the menu, I'll have the menu name, which is string, and then the cooking time and the quantity. All right. So that's those are all my my structs, and obviously I need access to Rust SQLite because I'm going to be working with the database related stuff here. I have Surdy, and then I'm going to get my Rust SQLite connection that we've seen before as well, and I'm going to get Surdy and serialize, comma deserialize. Okay, so now everything makes sense, everything is connected, and we have all the structs. I now want to create functions for each of these structs. So for example, for the table struct, I'll have some functions. for the menu struct, I'll have some functions here. And for the order response struct, I'll have some functions. And for the order item, I also have some functions. And I'll have some, yeah, that's it. For all of these structs that are defined, I'll implement some functions for all of these structs. So now I have all the models, as you know, all the structs, and I want to create functions for all of these structs. But before that, I need some handlers. Now, the handler file is about 700 lines of code. So what I'm going to do, like more than 700, actually 740 lines of code. So what I'm going to do is I'm going to focus more on piecing the things together and explaining more to you. So the first thing that I'm going to do is I'm going to get in all the imports. So I'm going to get the create models that I just created. I created order response, order item, order request body, table, menu, menu response, all the things that I just created in models. So I just first got all of them. Then I obviously need the SQLite connection, SQLite params. I need both of these. I need warp because obviously I'm working with the warp framework. I need some random number generation I'll be using in a while, and JSON that we've always been using up until now. But the first function that I'm going to create is the list table handler. So there is the list table route, and it's calling the list table handler function and passing in just the connection. So what I'll do is I'll go ahead and create that function here. Okay. And this is the list table handler function, takes in the connection, and the result is either a reply or which is of type, which is a part of warp, or a rejection. Okay. And then I'm going to go ahead and if I am able to get all the tables, right, which everything is okay, I'm able to get all tables, I'm going to reply with the tables in JSON, and I'm going to send a status code of OK, which is 200. If there's an error where I'm handling like this, I'm going to return with an internal server error. Okay, so that's the only difference. Now, the other function that I have is the create table route function, which is calling the create table handler function, which is requiring the body, request body. So you have to pass the body, we have to work with the body as well. To work with the body, what I'm going to do is I'm going to first create the function, which is the create table handler function, takes in the connection, takes in the data, which is of type table. And everything else is the same, like you get the reply and rejection. And here, I'll return the table ID, right, for the table created. And then I'll do some error handling as well. So let me go ahead and bring that in here. So what's happening here is when we're trying to create a table, right, we want to check if the table already exists. So if the table already exists, we are saying it's already created, not a problem. But if the table doesn't exist, so we say OK sum means table exists with that ID, and OK none basically means the table doesn't exist. And if the table doesn't exist, we are going to create it. So we're going to use the table create method to be able to create that table for ourselves. And we're going to again pass the same status, which is status code created. Now, while creating a table, if there is an error, we'll handle it like this. We'll say internal server error. And this is for the outside loop, this error for the outside bracket, which is when we were checking if the table existed with that ID. So if it didn't exist, if we had some problem while checking for that, we're going to return internal server error. So those are two error handling that's happening. Now we want to create a function for the list menu handler. So if you remember, there is a list menus route, which is calling the list menu handler. And this function is straightforward, just taking in the connection, that's all. So this function will also be, it's going to look very much similar to this function. And what I'm going to do is I'm going to go ahead and bring it here so that I can explain to you. And what this does is it just takes in the connection, that's it. And result, it's going to be reply and rejection. And we're going to list the menu. So we're going to call the menu list function with the connection string. If you get the menus, you will reply with the menus in JSON. If you get an error, you'll reply with an internal server error. Now, just like I had the create table handler, I'll have the create menu handler. So just like I have the create menu route, which is calling the create menu handler, which takes in the connection and the request body. So I'm going to go ahead and bring in the function here so that I can explain it to you, because it's going to look very similar to the create table handler. So create menu handler looks very similar to it in the sense it takes in connection and data, return replies with return and or rejection, like a reply or rejection. And so we check if the existing menu exists, right? If it does, we'll say created. If we were not able to find something like that, we'll create it. So we'll use the menu create method and create that menu. While creating the menu, if there was an error, we'll handle it with this internal server error. And while checking if that menu exists, if there was an error while checking, we will reply again with the internal server error. So we'll handle both of those errors. And now, just like create table and create menu, I have a create order route also, which calls in the create order handler. So I want to create a function for that. So create order handler. I'm going to go ahead, copy and paste it here, bring it here. And then try to explain to you how that works. So this is my create order handler function. It's a little longer than the other functions, so that's why I'll just need a little more time to explain to you. So what's happening here, the reason it looks a little longer is because we're, if you notice carefully, we are so yeah, in the create order handler. So this function, if you notice carefully, what's happening is we're running through some for loops. Now let me explain to you why that's happening. So in the create order handler function, what you do is you start with table IDs and menu IDs. If there are no menu IDs, then you say bad request, please add some items, which is perfectly fine, just a quick check. And then what we do is we check for the order response. Okay, match order response, get existing order ID. So if we were able to find an existing order ID here, then we perform some action. And if we were not able to look like okay none and okay sum, so we're following okay sum, that means we were able to find an existing order ID with this order ID. If not, then we actually go ahead and create it. That's why we say order response create. Okay, so that's why there are two big flows happening. One is when we find some order ID, one is when we don't find some order ID. Okay, and if so, there are three options obviously: found some order ID, didn't find some order ID, and then could be an error. So for the error, we'll return with internal server error. Now let's go inside this flow and see what's happening. So if we found that order ID, what we're going to do is we're going to run a for loop on the menu IDs, all the menu IDs, and then we know that for menu ID, for a menu item, there is a cooking time. So that's why we're using random generation. So we create any random cooking time for that item, and then we get existing order item ID for that order item. And if we are able to find something, then we match, we basically add quantity of, basically this is just updating the quantity of the existing order item if we were able to find that order item ID. If we were not able to find, or if there's an error, then we'll just say internal server error. Okay, and then here, so we're still inside the menu IDs loop, and here if we were able to find the order ID, then this happens, which is okay sum. And if we're not able to find the order ID, then this happens, which is we create that order item. For the order item, require the order ID and the menu ID and the cooking time. Cooking time, as you know, is being generated randomly. And if there's an error, then we'll say internal server error. And then finally, with finding like okay sum, which is finding that order item ID, and not finding it, like okay none, not finding it and creating it. There's the third option is the error, always which is the internal server error. So that's what's happening inside this for loop. So we go through across all the menu IDs that we find for that order and do this for all the menu IDs, and then we update all of those. And that's why here finally, when we come outside the for loop back into the order response order ID loop, before we close it, we say success, all order items updated successfully, because we loop through all the menu items and we have updated them successfully. Okay, and then if you were not able to find the order ID, you know you've gone through, so you know that this okay none code block is executed, and for that you just create that order response. To create it, you again go through all the menu IDs and you create the random cooking time, you create that order item for it, and then you handle the error, and if everything is okay, you say created, that it was created, and if there's an error again, you just say internal server error. And then finally, for the outside loop is the we've seen this error. This is for this loop, which is the OK none and OK sum, right? So this is the error for that, for handling those three conditions. Along with those two conditions, this is the error. Okay. So very quickly, I'll go through it again in case you're finding it difficult. What is happening here is you get the table IDs and the menu IDs, and then you check for the menu IDs length, and then you match. Basically, you get for the order response, you get existing order ID, and then you either get the order ID or you don't get the order ID. So OK sum and OK none. And this error, which is internal server error, is at the level of OK none and OK sum. Okay. Right, so we have the OK sum, OK none, and the error. So now let's go inside each of these. So for the OK sum, that means that the order ID was found, the existing order ID was found. We will go through all the menu, so one by one. So you get access to menu ID and menu ID. So one by one, you go through all the menu IDs, create a random cooking time. You then get existing order item ID. Remember, this is not the order ID, this is the order item ID, which is inside the order. There are multiple items, so you get that one by one. And if you found it, you will update the quantity of that, and otherwise you'll just return server error. And if you didn't find it here, so while updating the quantity, if you face an error, you'll return internal server error. And if you found the order item ID, this will happen. If you didn't find it, OK none will happen. This part will happen. This is, remember, we're still inside the for loop for menu IDs, and we'll create that order item. And we'll return the JSON. And then finally, the error is the internal server error that we'll handle. And finally, when you're outside, when you escape the for loop for the menu IDs, and you're still inside when you found the order ID, when you're still inside that, you'll return success, all order items updated successfully, because you've gone through all the menu IDs and notated all of them. And if you didn't find that order ID, so it's OK none, then you will create it. And then again, inside that, you'll have to go through all the menu IDs and create, let's say, the random cooking time, and create the order item for each of these. And and then if there's an error, you return internal server error. If it was created, you just reply created. If there was an error in the outside loop, you say internal server error. And this error, you remember, is the outside one, which is for the outside OK sum and OK none one. Okay, so this so we've done the create order handler function. The next function we want to create is the list order handler. So let me go ahead and get that here. So the list order handler function is very straightforward. You for the order response, you list all of them. So if you got the menus, then you will reply with the menus. You'll send back with status code 200. If there was an error, you'll just return internal server error, because you just take in connection. So there's no menu ID, there's no anything. It's just taking in the connection. That's it, and replying with all of those values. Now the next function here is the delete order item handler function. Sorry. Before I work on this function, I want to finish a few functions in my models.rs file, because this function is going to be a bit long and is going to use a lot of functions from models.rs, so it's best that I complete some of those. Now, I told you in my models.rs that I'll have some implementations for these structs, and I'll have some functions for these. So in my IMPL table, I'm going to have a create table function, which is going to have connection to my SQLite and the table itself, data for the table, and it basically inserts into tables the values. And when you see this question mark 1, basically means it's going to be substituted by this params, which is table.code. Okay, and then you return the last inserted ID, which is being sent here from here, result I64. Okay, so this is what creates the table. Now the other function here that I want to create is listing the tables. So I'm going to go ahead and I'm going to create that function quickly, which is listing the tables. So it just basically selects star from tables. That's all that happens here. And we return that in the table response, all of that. And the other function that I'll have here is the get existing table ID. So it takes in the connection of the table, and it says select ID from tables where code is equal to, when it says question mark 1, it's going to basically replace with the with the table code, the params, and then we'll return that, basically getting existing table ID. Okay, so I have these 3 functions for table. For a menu, again, I'll have the standard create function to help me create the menu, which is basically inserting into menus the name and values. Where you see the question mark 1, you mean that it's going to be replaced by menu.name, which is the params. And you see in the response that goes back from here, the result is I64 SQLite, which is being sent as, which basically the last inserted ID is being sent there. Now, the next function here is going to help me list all of the menu items. So it's basically read all function from the database, which is select star from menus, and you send back all the rows. Then I have the get existing menu ID function, which is similar, or actually exactly the same as the get existing table ID, where I accept the connection in the menu and then select ID from menus, where name is equal to, it's passing the name here of the menu, which is question mark 1, which is the menu.name being passed here, menu data, and you return that. If there's an error, none. If like if nothing is found, none, and something is found, then you send it this basically. And then for the order response, I have a function called create. So I'm going to go ahead and put it here. The create function does insert into orders table ID and then the values. So because to create an order response, you need a table, because orders are related to a table, because the table places in orders. That's why we have the table ID as well. Then the next function that I have here is the listing function, which is going to list all of my order responses. So select orders ID, orders.table ID, t.code from orders, join tables as t on orders.table ID, t.id. So that's where I'm getting all the data from. And then I'm going to get existing order ID. So I'm going to go ahead and add that there. So select ID from orders, where table ID, which has been passed in the function as a params, is going to be replaced here in from the params, and I'm going to create my query, run the query, and send back the response, as you can see here, or the response could be error. Finally, I have 2 more functions here in this for order response itself. So I'm going to go ahead and add those also. So one is the calculate total cooking time for that particular order ID. So it says select sum and cooking time from orders. So basically where the order ID is the one that we are passing. So we're going to get the total cooking time. The total cooking time comes from, we have these joins. If you see, don't be scared about these joins. Basically it's adding up all the orders, right? Because in one order there are multiple order items, so you want to add the cooking time of all those order items. So based on the order ID, so wherever the order ID is matching, you add all the order items and then you sum all of their cooking times. So in case you have any problems with these SQL queries, which are very basic, by the way, if you have any issues there, you can just put them in ChatGPT. ChatGPT will explain the SQL queries to you. Since this video is not about SQL, it's more about Warp, so I'm spending less time on it, but I've anyways given you a quick idea of how this works anyways, right? So it's not like you're not understanding what this is. So the last one is has items. So it checks if order has any remaining items, right? So order has multiple order items, so this checks if selects count star, so it's counting the total number of order items where order ID. So you pass the order ID and you get back the total number of order items that are there present on that order. Now the last one is order item, and order item also has a few functions. So the first function is the create function, which creates order items. So insert into order items, order ID, menu ID, cooking time, quantity, values 1, 2, 3, 4, which are the params which we're receiving in this function. And we return back the last inserted ID as part of the result from this function. Then we have our list all order items function here, which is simply going to select some values where order ID is equal to question mark 1, which is basically the params. So which is we're receiving here the order ID. So we want all these values where order ID matches this, and we create a nice little order item response with ID, order ID, menu ID, and from the row we get the particular value at the particular index 1 2 3 4 5 and create a nice response, spawn and send it back. Next function that we have is the list order items, where we're selecting particular fields from order items, and we're going to join based on orders, on where the order ID is matching the order items.order ID. So basically listing all the order items inside a particular for a particular table. Okay, so this is what we send back. So order item response, you get all of these values, and then you have the get item. So I'm going to go ahead and get that function as well. So this is the get item function. Let me check if the brackets are properly closed. Yeah, properly closed. So here we have slightly longer query where we're basically getting all the values like cooking time and orders, quantity, blah 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 from order items, where the order ID is equal to order items.order ID, and we're joining the menus as well, order table where the order table ID is equal to and order items menu is equal to. So 1 and 2, and 1 and 2 here are table ID and menu ID. So we're getting the items for the table ID and menu ID. Okay, so and we're creating a nice little order item response and sending it back to the user. Then we have a get existing order item ID function, and then we have the add quantity of existing order item. So we have these two functions. Now what this function is doing is it's getting the existing order item ID. So we select ID from order items where order ID is equal to 1 and menu item is equal to (2), which is 1 and 2 is order ID and menu ID. So matching those order IDs and menu IDs, you get you select the IDs from order items basically. So getting existing order item IDs. Okay, and these are basically helper functions that we are using in our handlers to get some values. So let's say a particular order item ID where we have the available order ID and menu ID. So that's where this will help us. And then you have the add quantity of existing order items. So how many existing order items are there? So like let's say from the order that you've placed, how many are there? So you cooking time is equal to cooking time divided by quantity into quantity plus 1, quantity is equal to quantity plus 1, where ID is equal to order item ID. So that's how you get the value. And this is the query. You execute the query, you get the value, you return back the value, or you can return back the error. Alright, so you have all of these functions now in your models. These are all helper functions that will help you with database related stuff. Yeah, all the database functions basically. And now in the handlers, when I am going to use my delete order item handler, I'm going to use a few of those functions. That's why I wanted to get this clarified. Okay, now I've copied and pasted the function. Now let me go through it so that it makes sense to you, because I'm going to be calling functions from here. So in my handlers, I've copied the function delete order item handler. It takes in my connection, it takes in table ID and the menu ID. Okay, so now it's going to execute this first query, which is the updating order items. And when I want to delete an order item, right? So I've kept the function names in case something confuses you. I've just kept the function names based on what this script is doing, the code is doing. So that's how the function names are created. So for example, the function name says delete order item handler. That's what it does. It deletes an order item from the complete order. So how do you delete an order item? You basically update the order items, and when you update order items, you have to reduce the cooking time, because now when in the order there are less order items, the cooking time will decrease and the quantity also will decrease, right? And where are you doing this? You're doing this where order items or order ID is in this, which is selecting order ID from orders, join tables on orders or table ID is equal to table ID, where table ID is equal to (1), and order items dot menu ID it's (2), and order items dot quantity is greater than 1. Right. So if there are more than one quantity of order items, that's where, and when you also match these tables ID and menu ID, which is being passed here in the params table ID and menu ID. That's where you're supposed to update the order items and reduce the cooking time and quantity time. Okay. Now you match the result that comes back after running, which is, if you see here, it's let result is equal to this query. So once you've executed this query, get back the result, you match the result. If the result is updated, then you check if it's updated, if more than quantity of 1 has been updated, then you'll just say that menu current quantity was updated successfully, everything is perfect. Otherwise, you say quantity is 1, delete the order item. So delete from order items, where order items order ID in, select orders.id, blah 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 blah, where tables ID is this and order and menu ID is this. So table ID and menu ID get replaced from here. So if it's more than 0, you say everything is fine. If the quantity is 1, then you actually delete the order item, and then you match the delete result, okay, which is this. So now we're still in the else. So all of this is happening in the else loop, in the else code block. So because the delete result is what we want to match. So if so here we'll have order ID result is equal to order response get existing order ID, and we'll match the order ID result, which is this, which is get existing order ID is a function that we have just created here, get existing order ID, right? It's a function here somewhere. This one, get existing order ID. So here you call that function, right? So whenever you see something like this, you're basically calling the function from models.rs, and you match the values of this. So if you got some order ID, then you check if that has any items, and you check for has items. If it's if there are no more items, then you delete the order as well. If there are items, then you say menu deleted successfully, and if there was an error, you'll say internal server error. And now we are exiting the OK sum, and after that we'll just, if there's nothing there, no response there, then we'll return internal server error. And again we'll now come out of this OK, which is matching delete result. After outside that also we'll return internal server error. There was an error while checking that, and now finally we're outside the updated block. So because we wanted to run this query, and then we were running all of this inside the updated, like that, if it got updated. But if it didn't get updated, then we'll run this part, which is the error, because if it didn't get updated, obviously there must be some error. So that's why we've handled the error out here with internal server error. Now the next function is going to list the order items for table handler. So we have listing the order item for table handler. So this takes in the table ID and the connection, and you call the function list order items. So here you have a function called list order items somewhere, pretty sure. List order items, this function which takes in table ID and connection. So after that you get the items, you send back status code OK, which is 200 with the items. If there's an error, you'll say internal server error. Now the next function is finally the final function is the get order item for table handler. This function also get order. Sorry, yeah, just the get item. Yeah, so just get item is here somewhere. Let me actually just search it very quickly. It will just to save time. So we have get item here, right? This is the one that we're calling. As you can see here, get item. And if we get back the items for the table menu and the menu ID, the table ID and the menu ID, you return those items. Return that item. If you didn't find anything, you'll say not found. If there was an error while performing this, you'll just say internal server error. And now what we'll do is we'll write some tests. So this is a bonus section of this video. I'm going to show you how you can write unit tests for your code, for your Rust code. So I'm going to go ahead and copy and paste all the unit tests and explain to you one by one what each of these tests are doing, so that you know how this works. And then I'll explain the test to you later. Let's actually go ahead and create the client quickly, because that's a smaller task. So what I'll do is I'll first get in all the things that I want, like request client, to make the request. So as you remember, we are going to be making requests from the front end to the back end. We're going to be making API requests. So that's why we need the request client. And these requests are going to be concurrent. As you saw in the demo when I showed you that some were getting resolved even though they were later in the series, like 5th was getting resolved like earlier than the first one. So everything was happening concurrently. So that's why we're using requests, and we're going to be running concurrent requests to our backend API. And then you need JSON, you need slice random. I'll show you where we use it. And then you have the time, which is duration and timeout, to be able to work with time. And now we'll create a function. The first function helps us create all the tables. So we create, so the table codes are this: T1, T0, T2, T3, T4, T5. And then you, from 0 to 5, you simulate how you can create a table. So we call our localhost 3030, which is where the application server is going to be running, app server. And then you create all of these tables. And I'm going to push in the table IDs all the tables that were just created. Okay, so I'll return all the table IDs that were just created. So table ID is created, and now the next is I'm going to create all the menus. So I'm going to simulate how a menu will get created. So instead of calling these APIs from curl command or from Postman and creating those collections, we're just calling those APIs from the Rust client itself, and we're creating the menus one by one. All 5 menus are created, and we'll loop over 5 times, and then we'll call the API for all those 5 menus, and those menus are created. Okay, and we return all the menu IDs that are created. Now I'm going to simulate what an order looks like. So that's a slightly long function, but before that I will write my main function, because the main function is where this enters in from, and it runs. So I'm going to create, so I'm going to get my table IDs from create tables. Create tables function returns my table IDs, as you can see is Victor I64, and I get my menus ID from my create menus function, and I get all my menu IDs, and I create my client, a new request client basically. So client I get from request, and with the help of request I create my new client, and I call the order simulation function with my client and my table IDs and my menu IDs. So by now I have called these 2 functions. I've got my menu IDs and table IDs, and now I'll need that along with my request client to call the order simulation function. So let's copy and paste the order simulation function. That's a slightly longer function. So I'll go ahead and copy and paste it. And here, firstly, you simulate concurrent requests. So you, what you do is you use Tokyo Spawn, okay, with the client and the table IDs, and you create an order first. So to create an order, you hit this API localhost 30/order/create, and then you're passing your table IDs and your menu IDs, which is there in your menu sub array, if you can see here. So menu sub array is equal to menu IDs, which you've received in this function as params, to vector. So you're passing that as vector menu IDs. And then if there's an issue, you'll say fail to create order. Otherwise, you'll say fail to pass response. After the response had come, you'll await for it. And if everything went fine, you'll say created order for table with menus, blah, 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 blah. And then you'll wait for a second. Then you'll get all items from order by table ID. So you'll call this API, which is localhost 30 tables slash table ID, which will, the table ID will go here, and for the table ID we'll get all the items. So we'll get all the table all the items from order for that table ID. If there's an issue, we'll say fail to get all items, and we'll use JSON to convert that into JSON, and then we'll say fail to parse response if that failed. Okay, and then we'll go over those items, and we'll get the menu name, booking time, quantity, and all of that, and create a new array and push everything there. And the new array is a vector containing desired fields, and we'll print all of that out to the terminal, and then we'll wait again for 1 second before going to the next step, which is getting specific item for that table. So again, we'll call this API, which is tables, and then we'll replace the table ID and the menu ID for the table, all the items, and fail to get the specific item. You know, you have the table ID, for that table ID you have the specific item, you fail to get it. Again, try to convert into JSON, and then you can say fail to parse response if there's a problem. And then we'll say menu from table is menu and cooking time is this much, quantity is this much, and you'll print out all of that to the terminal. Then you sorry, and then you'll wait again for 1 second, and before you go on to the next step, which is removing one item from the table. So you call the order/item/API, and you pass in your table ID and menu ID here, and then if there's an issue, you'll say fail to remove the item, otherwise you'll say fail to parse response, and you'll say remove menu from table, blah 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 blah, and pass menu ID, table ID, and response. Again, wait for a second, and then you'll wait for all the tasks to finish, because everything is happening here for handle and handles. You'll wait for everything finished, and everything is then done and finished and good to go. Because handles was this vector 0 to 10, and we'll wait for all of the tasks to finish, right? Those were the different specific tasks we were spawning. So now at the end, everything will be finished, and then that's what your client does. Now coming back to handlers and all the tests, let me quickly take you through all the tests, right? I've written all the tests for you. You don't have to do anything. You just have to run cargo test. So it'll run all the tests for you. But let me explain to you very quickly what is happening here. If you've reached this far, that's really awesome, guys. I just want to tell you about the 6 AI plus Go projects advanced course that I've recently built. The link for this will be in my description of this video. And in this course, we build 6 awesome projects. So if you're looking for a job in 2024, then AI is definitely what you need on your resume, and that's what the HRs and recruiters are looking for. And you need to really upskill yourself. So I've created this killer course where you'll build, it's 26 hours of content. You'll build 6 killer projects, and extremely detailed planning exercise is there for each project. You have well-documented code. Each line of code is explained, and you get real-world high-value projects, which are production-level projects you get in this course. Make sure you check it out. This will really help you and really add a lot of value in your resume. All right, now back to the course. So before I take you through the tests very quickly, let's update our cargo.toml file for the app server, right? So that's my, I'm using Tokyo, SQLite, Warp, Serde, JSON, and random. And for my client server, which is out here, I am going to again update it. So my client server, I'm using again the same things. Tokyo request, Serde, JSON, and rand. Okay, all of these things. And yeah, that's about it. Now let's go back to, I'll close all the other files. Let's go back to the handlers, talk about the tests. So I'll quickly go through it. So what's happening here is, first you check your connection with the database, if everything is fine, right? And then you try inserting static table and menu data into the database. And then we convert the warp response to Serde JSON value, check if conversion is happening, the response to JSON is happening. Then you check for menu creation. So is the menu creation happening out here? Check for that menu creation. And then you check if the table creation is happening. So all of these are test cases I've written. So it basically has some code to check if the menu is getting created, the table is getting created, and if the order creation will fail with the wrong data. And there's another function for the same thing. If the order creation will fail with the wrong data, so that's why it says wrong data too. Then the test case 4 is about order creation with the correct data. So does it work or not? Then test case 5 is removing item from a table. So how do you remove the item from a table? Does that work? Then removing all items from order will delete the order. Does that work? Okay. Then I have removing item having quantity more than 1 will reduce the quantity of the item. Does that work? Okay. And then getting specific item from a table, you check for that also. So I have all the tests here. Now I'm going to try to run my application server, and then there will be many errors, and we'll fix them. Now instead of running the tests, what I'll be doing is I'll be just running that directly, like just running the server directly, because I like getting errors here in the terminal, and then I fix all of those. Like it's just easier for me to fix those because it's much clearer. So I'm gonna go ahead and say cargo run in the app server, and of course we're going to get a lot of errors, and that is completely all right. And before that, I'll just take some time to build and run the project. right? So of course we got a lot of issues, and let's go through them one by one. Okay, so here it's saying use a double colon instead, like this, on db.rs line 4. Okay, db.rs line 4. Just a second, I'll bring it back here, and db.rs line 4. Okay, so here it's asking me to use a double colon, which I agree that I should have used that there. And the next issue it's showing me is that on routes.rs line 24. Okay, so here what seems to be issue, I'll just put a space here anyway, even though that's not leading to an issue, but I'll just here there should be a double colon here as well. Makes sense. Okay, and then on, so it's again telling me to use a double colon instead, blah 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 blah, so which is perfectly fine. There's something on line 100, which is this line, public create menu route. Okay, what's the issue here? Let's see. Let me actually read what the issue is. Public function, add the function here. Yes, I've not added function fn. Okay, it's very, very stupid. And cannot find function restaurant routes in module routes. Okay, this is main.rs line 10. Restaurant routes, cannot find this function, and it's saying this here, restaurant routes. Restaurant routes. Okay, anyways, I hope that should fix it. Maybe there was some error or some typo before. I'm not sure. Here on db.rs there is expected connection found this. What does that mean? db.rs line 3. Okay, db.rs line 3. Function get db connection, and why is it saying that it got something else when it was expected connection? Because I have given the connection. Oh yeah, I have to return the connection, sorry. That's why it's what is expecting connection, because I have to return it from this function. Anyways, and consider the local blah 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 blah. Yeah, I think now is when we'll get all the extra errors. So here also I have to use double colon, which is routes.rs line 32. Line 32. Okay, that makes sense. Then you have cannot find function reply with status and create warp reply with status, because it must be like a capital S or somewhere. Line 30 of routes.rs line 30. Okay, reply with status. Routes.rs. Reply with status. Okay, because it's reply, so I'll have to make the change everywhere. It's actually reply and then with status and reply and then JSON. Let me try to search if I made that mistake somewhere else. Reply. No, right? Yeah. Okay, I fixed that. And I'll just run it again, see how many errors actually go away. All right, and then you have line 41. Here you'll the reply spelling is wrong. Okay, routes line 41. The reply spelling is wrong. Okay, and here you reply line 49. Again, spelling of reply is wrong. And then you have again line 57. Oh, I've made the same mistake everywhere. Reply. And here also it's, oh yeah, because I copied and pasted, right? So one mistake made in one place is going to show up everywhere. It's brilliant. Okay. Now let me try to run the code again. And it says no method if not found. So routes line 19. If error if not found is not found. Okay. And then fail to resolve warp reply, which is line 31 of the same file, right? Line 31 warp reply. Yeah, makes sense. And then you have on line 32 internal server error, should be internal server error. Now I'll run the code again. And okay, so failed to create table orders, SQLite error, incomplete input. Okay, so it's creating the creating the menu table, order table, and then it gives you a little bit of issue here. It says failed to create table orders. Well, actually, oh yeah, because every single time what we do is we create the table, we print out that we're creating a table, and then we actually create a table after that. So let's go to our db.rs. So create order table and create order item table. So these two things have not happened like we wanted them to. So I'm going to check if create order table if not exists. If this is create order table, if not exists, I'll replace the name in case there's a typo here. And create table if not exists, orders, ID, integer, blah, 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 blah. References, table, unique. Yeah, but it should work now, hopefully. Let me see. Okay. Unknown extend one. So now incomplete input. So it's maybe there's something that I'm not sending. Create order table if not exists. Create table if not exists, and orders and ID, integer, primary key. Table ID is integer, not null. Foreign key is table ID. Reference is tables ID, and unique table ID. Let's put a space here to be sure, and then there's a bracket that's not getting closed here. Yeah, I didn't close. I think the bracket was not closed, but I'm not sure because this bracket was not getting closed, right? So I just close it. Hopefully it should work now. It's just the problem with the bracket. No, still I think there is some incomplete input. What I'll do is I'll fix all of this and then I'll push the code to GitHub, okay, so that you don't have to worry about fixing this issue because SQLite is not giving me a proper output and it's just saying incomplete input. I'll figure it out. I'll put the right code on GitHub. You don't have to worry. You'll get the fixed code. And what I can do is, again, I can show you the output from the fixed running code. So here, as you can see, all the Rust errors are gone. You're getting all the tables created. Even now, order item table is also getting created. Earlier, that was not happening. But now, to create table orders, there is some SQLite failure happening, which is some incomplete input is happening here. That's the only thing that's left. And yeah, we can also try running the client server just to see if there's any issues there. So client server and cargo run, just to see if there are any issues there. Oh, here also if the bracket is not closed. Actually, I think this should work now. Failed to create table, blah 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 blah, because the table is not getting created, right? So I'll have to go into the app server again and run cargo run. Now let's see if it works. Whew. Imagine now it's working. It's just one bracket out here. Closed it, and now everything works fine. Awesome, right? Now what we'll do is we will open up another terminal, and I'll just shut this down, and I will now go into resto warp yt cd client server, and here I'll just cargo run. So I'm creating all the tables, as you can see here. Successfully tables are created, and then all items from the table have been fetched, created the menus for the table, and then removed the menu from the table. So the project is working amazingly. Like it's completely perfectly fine. And thank you guys so much for watching this video. Do check out all the other playlists that I talked about on my channel. Do share this with your friends, because this is like awesome free content, right? And if you don't tell other people, they will never know, and they won't learn Rust the way you're supposed to learn Rust, which is by building projects. Thank you so much for watching, and I'll see you in the next video.